So Barry is running along the shore of a lake as fast as possible. He knows that if he stops, his life will turn into a nightmare in no time. 1,000 mosquitoes are about to bite him. But what he doesn't know is that he'll be okay after all. So don't be afraid, Barry, and stop. Mosquitoes are slow. They fly at a little more than 1 mile per hour. And you can't run forever. So after a couple of hours of pointless running, Barry stops. He sweats and emits a smell attractive to insects. One little mosquito flies up to him. It buzzes next to his ear, sits on his sweaty neck, and bites. The insect pierces the skin with a special mouth apparatus called a proboscis. The mosquito starts pumping blood through this needle. Its saliva gets into Barry's body and causes an allergic reaction. More precisely, it's Barry's immune system that starts this reaction. It perceives the mosquito's saliva as an enemy and sends a unique chemical substance to the bite site. The fight between this substance and the invader causes an allergic reaction, redness, swelling, and the worst thing, itching. Barry can scratch himself for several hours or even days. It all depends on how his body will react to the bite. The mosquito fills up with Barry's blood and flies away. It does it not for pleasure, but because it needs to lay eggs. Protein in the blood is necessary for these insects to reproduce. Their eggs can't grow without this substance. Yeah, almost all biting mosquitoes are female. Male mosquitoes prefer plant and flower nectar. Hey, they're guys. So the female mosquito flies away from Barry. She sits down on the shore of the lake where a large mosquito base is located. Here, these insects lay eggs, drink water, and chill in the sun. There are several 100,000 of them, and they're all hungry. The female mosquito brings with her the smell of Barry's sweat, which is attractive to the rest of the mosquitoes, too. There are about 3,500 species of these insects on Earth. Some of them love the smell of sugar, perfume, or deodorant, and some enjoy the smell of dirty feet. Now, your attractiveness to mosquitoes also depends on what you have eaten today. Lots of candies and chocolate? Great! Now, mosquitoes feel a faint sweet smell coming from you. Have you eaten garlic and onions? Mosquitoes probably won't want to deal with you. And not only they, most likely. So, the smell of Barry's sweat is perfect for all mosquitoes on the shore. They go mad, take off, and head for the poor guy. If you walk near the water when the evening comes, if you're sweaty, wearing black clothes, and have O-type blood, then you have all the chances to get bitten by mosquitoes. And Barry meets all the criteria. The first mosquitoes land on Barry's feet. They bite him and start pumping blood. One tiny mosquito can draw a droplet of blood the size of half a grain of rice. It's nothing at all. But several dozen of these bites? It's bad. Barry fights mosquitoes off with his hands, but the insects keep coming. They can't miss such a delicious dinner. 10, 20, 50, 100 mosquitoes. They cover Barry's legs. The skin swells and turns red. Barry feels a burning sensation. His immune system is working at 100%, trying to reduce the damage and drive the enemies away. But the more actively Barry's body defenses work, the worse he feels. Mosquitoes sit on his hands and on his wet t-shirt stuck to his body. Yes, their mouthpiece can pierce a thin layer of fabric. Barry tries to run away. He stumbles over a rock and falls. Some insects finish their feast and fly away to tell their friends about the free food. Mosquitoes from all over the lake come to try Barry. 200 mosquitoes are drinking his blood. 3, 5, 7, 900. Now 1,000 mosquitoes have bitten him. Together they have pumped out a small glass of blood. But the worst thing is they continue biting him. Nothing can stop them now, even though they were supposed to bite him only 1,000 times. Well, the only chance to escape is water. Barry, ignoring the itch, gets up and runs to the shore of the lake. Meanwhile, 100,000 mosquitoes have already bitten him. Sorry, Barry, but we have to entertain the audience. Don't worry, your recovery will be fast. He's getting closer and closer to the water. Mosquitoes are flying in front of his face, so he can't see the road. But Barry keeps running, waving his hands. Meanwhile, You know this moment when you're sleeping and one mosquito flies into the room through the window? Just one. But its squeaky sound is so annoying. And now, imagine 1,000,000 mosquitoes making this noise. It's like a saxophone playing high notes. Sorry if you're a sax player. Well, Barry is slowing down. He's exhausted, and his heart is beating too fast. He no longer feels bites and itches. His body is becoming weak, but he's still moving toward the lake. Mosquitoes have already taken 3 soda cans of blood from him, and this is serious. Barry is running a fever and has clouded consciousness. His immune system is not coping. Barry can't run anymore. He's struggling to walk. It's getting harder to make every next step. The shore is only a few feet away, but it doesn't matter anymore since he has no energy to move. So he just sits on the grass and accepts the situation. He's lost a large soda bottle of blood, and this is a lot. This is probably the most large-scale attack of mosquitoes on humans. And then, at the very last moment, salvation appears. A frog croaks nearby, and another one. Several dozen jumping animals are approaching the shore. They release their tongues like spears and catch mosquitoes. This gives Barry hope. He makes a last-ditch effort to reach the lake. He jumps in. Yeah! What a relief! Cold, fresh water envelops his whole body and relieves the itching and irritation from the bites. He waits in the water while the frogs dine on the mosquitoes. The remaining insects fly away. Barry crawls out of the lake. He sees frogs catching mosquitoes and realizes that these annoying insects are necessary for our planet. Frogs live thanks to these tiny monsters. And besides frogs, there are many other animals that feed on mosquitoes. Lizards, spiders, bats, birds, turtles, it's a huge list. Mosquitoes are an endless source of food for them. One pair can lay 200 eggs. They grow fast and their lives are short. But if all these insects disappear, an ecological catastrophe may begin. Entire animal species may vanish from the face of the earth. The frogs that saved Barry wouldn't exist. Without frogs, the population of other insects, like flies, would begin to grow. They would reproduce uncontrollably. And then, like falling dominoes, other problems will follow. So, Barry, don't be angry at mosquitoes. It's just nature. You better deal with your itchy problem. His whole body is red, covered with little bumps. He starts scratching himself, but this doesn't help. He only makes it worse. As long as mosquito saliva remains in his body and the immune system fights it, Barry will feel this itch. Fortunately, there are many oils and ointments to alleviate these effects. But the best way to get rid of the problem is to ignore it. Barry just needs to distract himself with something. Then the urge to scratch will disappear. Barry has survived so many mosquito bites without harmful consequences. But some people have problems dealing with just one. It depends on whether a person has allergies. Some have a small itchy bump, and others have severe inflammation. As for Barry, wasn't he swell? Didn't he swell? Okay, I'll stop. The best way to protect yourself is to use insect spray. Now, Barry sprays himself with this substance before every run and feels safe. But let's have a look at another situation. What if Barry gets attacked by huge dogs? Hey, just kidding. Relax, Barry.
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. Or vice versa. Or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking. It's a lovely day for a boat ride in the swamp. If not for these mosquitoes, then today would be perfect. But for some reason, the mosquitoes keep getting bigger the further you go into the swamp. They started out as tiny, almost invisible insects, and can now be the size of your thumb. You can hear their buzzing as they whiz past you. You go deeper to investigate why they're so big. Eventually, you see a large cluster of mosquitoes the size of your hand buzzing around. They notice you and start flying toward you. You grab a branch and start swatting them away. You run back to your boat and try to escape, but they follow you, and some manage to land on you. You swat them away, but more mosquitoes pop out of nowhere, the size of a basketball. You start your boat and speed your way back to the mainland. As you arrive, you see everyone running away in a frenzy, panicking because of the giant mosquitoes. Some of them are as big as a large dog. People are ducking under picnic tables, while some are running back to their cars and driving away. You get off the boat and run toward the closest grocery store, along with dozens of people. The employees lock up the gates, but the large glass panels show the mosquitoes multiplying. They're getting bigger and bigger until you can see one as big as a car zipping by. It's so strong that it landed on an empty car and crushed it. Everyone inside is ducking away out of fear. You try to calm everyone down and not make any noise. The mosquitoes are landing on the glass panel, blocking out the natural light. It's getting dark inside. Someone turns up the volume on the TV to the breaking news. Mosquitoes are flying rampant all across the continent, destroying natural resources and infiltrating cities. People are advised to stay indoors until further notice. The mosquitoes notice that there are people in the store, so they try to get in by force. A car-sized mosquito flies around in the sky, unaware of what's happening below. Everyone hears some noise coming from the back room. The employees realize they didn't lock the doors. A large mosquito enters and knocks down everything. Everyone runs around in a panic while throwing random stuff at it. Some people grab a fire extinguisher and spray it until it flies to the back room. Some employees lock the door and barricade it so that nothing can enter. Everyone waits nervously. The TV broadcasts some live coverage of how giant mosquitoes are flying everywhere. A helicopter is forced to land because the mosquitoes are flying around wildly in the skies. Everyone shudders when they hear the sound of more mosquitoes buzzing around near the back door. Hours pass, and more mosquitoes keep coming endlessly. There are no people outside, and much of the urban and landscape design in the park is destroyed or overrun by giant insects. Some people eat whatever is available, while some are sleeping. A piece of breaking news interrupts the live coverage and shows that there will be armored buses ready to pick up people near the picnic site. However, the buses won't drive to hotspots since it'll be too dangerous. The only way to get on them is by being on the highway in 2 hours. Everyone tries to call their loved ones, but the cell towers have been knocked down and no one can call anyone. The mosquito that broke in a while ago destroyed the only landline that was present. People are arguing about whether they should stay or go. More insects covered the only clear patches of the sky until the sun disappears. The people split into 2 parties, those who are leaving to catch the bus and those who want to stay. The employees know a back way that can quickly lead to the highway. The only problem is that it'll take around 20 minutes on foot, and there are no cars to use. The way is tricky. First, they would need to escape through the main entrance and head through the bushy forest behind the dumpsters. Over there, they can enter a building, possibly through the sewers, which will lead to the lake next to the highway. The first party decides to leave. They prepare supplies for the breakout. Every second, more mosquitoes arrive, covering the sky. They gear up with anything they can find to protect themselves. Mosquitoes are attracted to the carbon dioxide that people breathe out, and they know that there's a source coming from the grocery store. Once everyone is ready, they get some makeshift torches and light them up. They add some barbecue fuel to keep the fire going. You're part of the party that is planning to escape. The doors open, and everyone makes a break for it behind the dumpster. Many mosquitoes try to attack you, but the smoke from the fire repels them. Every second, more mosquitoes are filling the sky and the environment. Many people end up running back into the store since they couldn't make it past the dumpster to the other building. Eventually, the rest of the people, including yourself, run toward the building. But it's locked, and no one can break down the door. Plan B is to break the glass from a window and crawl inside. You grab a rock and smash the closest window. The only problem is that the mosquitoes can follow you inside. So without any options left, you pull through and run to the basement of the building to find the entrance to the sewer. Success! You found it, and everyone descends to the bottom. No mosquitoes in sight, just rats. You're walking knee-high in sewer water with it flowing past you, but it's only a few minutes until you reach the river. Another problem is that the sewer isn't going to the lake, but somewhere deep into the sewer channels. You follow it until you see what looks like an outlet. You make it out and are near a water hole where all the discarded sewage leads next to the swamp. The only problem is that you're not next to the highway anymore, and time is running out. More mosquitoes are swarming the air, but they don't bother buzzing next to you. You notice some cat-sized creatures floating on the water. These are baby mosquitoes, or the larvae, and they're coming your way. You and everyone else swim for your lives to the shore. The giant alpha mosquito soars into the air and swoops down to try and grab someone, but it misses. Everyone makes it to the thick, swampy area where no giant mosquitoes can enter. Everyone covers themselves with branches to protect themselves. 15 minutes until the armored bus arrives. Since the mosquitoes can't enter, this will be the best place to hide until then. Darkness falls, and still no bus. It's been 3 hours, and nothing. The mosquitoes are still buzzing around, and everyone is getting uncomfortable under the thick bushes. After a while, everyone hears a roaring engine and sees lights flashing on the highway. Everyone gets up and runs to the bus, but you stop them to not draw the mosquitoes' attention. You volunteer to sneak out and stop the bus, and then everyone else can follow without drawing too much attention. You move a couple of branches, step over some tree bark, and crawl to the highway. You try to hold your breath so that you won't make any heavy breathing sounds. You reach the side of the road and wave your arms to stop the bus. It pulls over and the door opens. You signal the rest of the people to follow, and they follow your lead. Everyone is inside and safe. Some mosquitoes notice and start pecking on the bus, but the armor is sturdy. The bus drives off, looking for other people along the road. And suddenly, a Goliath lands in front of you. The bus stops and sees a mosquito the size of a Boeing 747. It looks straight at you. It gets ready to attack, but the bus speeds under its legs and drives off. The Mosquito takes off and tries to catch the bus, but you enter a tunnel to the other side of the mountain. After a few minutes, you reach an open area with no trees or buildings. The bus is speeding while dodging obstacles along the way. Finally, you notice you are near the grocery store where you were held up. The bus opens the door for everyone inside to be taken to a safe zone. You hear from the aid workers that the whole world is being overrun by these giant creatures. As you drive along, you see a hybrid mosquito that has 2 heads and a scorpion's tail. It's as tall as the Statue of Liberty, and it's ready to attack. Whatever is causing these mosquitoes to grow abnormally is also making them into hybrids and mutants. And you thought it was going to be a good Monday.
A huge meteorite enters our atmosphere, causing an explosion of catastrophic proportions. All forms of life on Earth cease to exist. A giant wave of fire wraps around the planet several times until only ash and dust remain of the green landscape.
But then again, there's another option for our planet's future. The sun could swallow it.
Wait. Who is this?
In the course of its evolution, our star will keep expanding
Am I the only one hearing this voice?
until it gets so big that it just swallows our planet without even noticing it.
Hey buddy, that's my video.
I don't think so.
Okay, alright, I'll share it with you. But let's not look that far into the future.
Whatever you say, buddy. How about the fact that the Earth will soon have rings?
Like Saturn?
Almost. Saturn's rings are made of dust and ice.
Yeah, I've heard about that. Thousands of years ago, something really mysterious happened in Saturn's orbit. The planet's gravity tore one of its satellites apart.
Yes, Saturn is a gas giant. It's 95 times heavier than Earth, so it has stronger gravity. It attracted a small moon from its orbit to its surface. Then, it was torn apart from the inside by tidal forces, like the ones between Earth and Moon. Many huge fragments stuck in Saturn's orbit. Some scientists say there was a collision of 2 moons there. They crashed into each other like billiard balls. As a result, both cosmic bodies turned into a pile of debris and blocks of ice.
No matter how they got there, this debris started circling Saturn. They collided with each other, turning into smaller rocks. It was a kind of cosmic blender. Rocks gradually ground into dust, and huge blocks of ice turned into small crystals. On average, the objects are in the same ratio to these rings as a human fingernail to a school bus.
And soon, similar rings will appear around Earth.
But how? I mean, we have the moon, and it's hard to imagine that it could break apart at any moment. Plus, we don't have another moon to recreate the same collision in our orbit.
Space junk. We have a lot of it. We started launching spacecraft into Earth's orbit in about 1957, and it almost always follows the same scenario.
Ah, yes. The rocket consists of several parts, a booster, or even several of them, the second stage of the rocket, and a cargo, which is contained in a capsule at the end of the rocket. The booster accelerates the rocket to almost orbit and then undocks. The second stage fires up the engines and climbs even higher to get the cargo into orbit. Then the second stage undocks as well, and the cargo capsule releases the satellite or space probe into outer space.
Yes, the first and the second stages of the rocket and the cargo capsule were disposable. That means they stayed in Earth's orbit. Over time, our planet attracted them. They entered the atmosphere and burned up because of friction with the air. But many objects keep orbiting our planet for decades. As of 2021, there are about 170 million space debris objects in our orbit. These are parts of spacecraft, like the bolts used to undock rocket stages. There are also old artificial satellites, operating ones, functioning spacecraft, and debris from collisions that had already happened.
Oh, I've heard about that. In 2009, 2 satellites collided with each other. Both satellites were destroyed. They shattered into about 600 pieces of different sizes.
Yes, and these sharp metal fragments are flying in orbit at about 6 miles per second. So they could make a trip from New York to London in less than 10 minutes.
Yeah, that's about the same speed at which our rockets fly. And that's about 45 times faster than commercial airplanes.
So these fragments have a lot of energy. As they collide with each other, they shatter and become smaller.
Just like the moon debris around Saturn.
Exactly.
But a bunch of metal debris orbiting faster than the speed of sound can damage our spacecraft, right?
Yes. The International Space Station has already turned on its engines to maneuver once to avoid a collision with a cloud of space debris. Sharp metal parts can damage the hull of the space station or even puncture it. then the ISS, worth about $150 billion, would be destroyed.
So, if we keep throwing debris into orbit, we could really give our planet the rings.
And then they will be visible even during the day. They will reflect sunlight, just like the moon. And if you look out the window, you'll see beautiful stripes interrupted by the shadow that the Earth casts.
It's an amazing view. Do you want to see an even more unusual one? Imagine that our sun has increased in size by 10 times, and that process is happening right now. Our star is a giant boiler burning hydrogen. It's continually heating up, and every billion years, the sun gets 10% brighter and creates more heat. It'll heat the Earth more, and eventually, the oceans and seas of our planet will begin to evaporate. Thick clouds will completely cover the sky, turning Earth into a giant greenhouse. Our home will look like Venus.
Looks like humanity will no longer be able to live on Earth. What will we do then?
Well, we'll load all the humans and animals into spaceships and move to Mars. At that point, the sun will have warmed it up nicely. Water and carbon dioxide deep in the planet's interior will begin to evaporate and create an atmosphere there. This will cause a greenhouse effect and warm up the planet enough for you to wear shorts there.
And then we'll watch the Earth become a lifeless rock with acid clouds like Venus from the surface of Mars.
Yep, but in about 7 billion years, the sun will start to expand even more and become a red giant. In this phase, it'll become 256 times wider than it is now. So it will completely swallow Mercury and Venus, and the edge of the star will lie just in the orbit of Earth.
So our planet will just drown in the hot plasma on the sun's surface?
Maybe. But when a star burns so much fuel, it loses weight, and so the sun's gravitational field will weaken as well. So it won't keep the planets of the solar system as close to itself anymore. Perhaps our planet's orbit will become wider, and then Earth will become the first planet near the sun. Some scientists believe that, at this time, Saturn's moon Titan may gain conditions suitable to become a new home for humanity. Then the sun will begin to shed its upper layers. It'll lose mass and gravity dramatically. This will plunge the solar system into chaos.
Some planets will collide with each other. Others may just fly away into the far dark space. It would be a game of cosmic billiards.
Exactly. And the final stage of the sun's life is a white dwarf. Then our star will become the size of Earth. The planets that survive won't get enough heat from the white dwarf, and its light will gradually fade over billions and trillions of years.
Another challenge that awaits Earth in the distant future has a galactic scale.
The collision of the Milky Way and Andromeda.
Bingo! Right now, the Andromeda Galaxy is moving toward us at 60 miles per second. You could make a trip around the globe at that speed in just 6 minutes.
Yeah, you can already see the stars and gas of Andromeda Galaxy in the night sky with an unaided eye at 2.5 million light-years from Earth.
And in 4 billion years from now, the galaxies will begin the process of merging. No one could be 100% sure about what will happen to the Earth. It could be total chaos when the stars and nebulae of both galaxies collide. Then supernova explosions would go off everywhere. Like fireworks.
But this is extremely unlikely to happen. The concentration of stars and space objects in galaxies is very low. The distances between them are gigantic. It's like if you took a handful of sand and scattered it all over the planet.
The most likely scenario is that by the time the two galaxies do collide, there will be no liquid water on the hot surface of Earth. That would mean the end to all terrestrial life. Scientists believe it can happen in about 3.75 billion years.
You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy, since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, The asteroid 1990 MU. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, It would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produce to prevent the asteroid Apophis from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. a powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the Sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. Cold and seemingly infinite expanses of the Arctic. The white of the snow is blinding. In this vast and empty space, there's a dark dot. Getting closer, it turns out to be a small research station. One door and one window. An old antenna on the roof wobbles from the strong winds. You're sitting inside this hut in warm clothes, drinking hot tea. An electric generator hums under the table. It's connected to a TV and game console. You take the gamepad and select the video game you want to download. It's about 650 gigabytes. It seems in such a place it will download over several centuries. But you press the button and the game is downloaded on the console in less than a second. Welcome to the world with the fastest and most accessible internet. The internet already works at the speed of light. Phones use a specific frequency of radio waves that travel at the speed of light. You're watching this video using the internet at the speed of light. Most of the data is transmitted through a copper wire or fiber optic cable. This happens so fast that we won't notice the difference whether it's transmitted at the speed of light or not. Wi-Fi also uses radio frequencies to transmit signals between devices. The fact is that the speed of the internet is not about how fast a file travels from one device to another. It's about how much data is transmitted over a certain time. So, let's imagine that data of any size can be loaded at the speed of light. 300 gigabytes of several movies in 8K, 400 gigabytes of a video game with ultra-realistic graphics, 1 terabyte of a project for a graphics editing application, and all of this is downloaded to your device in 1/100th of a second. The internet is a connection between computers. For everything to work correctly, the computers connect to a router. This thing works as a controller. It makes sure that the message from one computer reaches the other without any confusion. When there are too many computers, you need more routers that connect to other routers. You can scale this network indefinitely. To connect millions of houses to the network, developers can use telephone cables. To make this complex system stable, it's served by internet service providers. They're companies that we pay money to access the internet. In simple terms, all information from the internet is transmitted via a cable directly to the Wi-Fi router. It uses radio waves to wirelessly transmit data to a computer or phone. Your devices are also equipped with an antenna that can catch and transmit signals via radio waves. The speed of the internet slows down when it goes through different routers, receivers, and other technical hurdles. The cable may be damaged. Providers limit the speed intentionally and increase it when you pay more money. Also, the speed of the internet is affected by the number of users connected to the same network. It's like a broad highway with a traffic jam. The more cars there are driving on it, the slower they move. Just like that, your data is loaded onto your devices. To spread the internet at the speed of light everywhere, developers need to improve cables data passes through. The number of networks and routers should be increased. The jammed highway will become even broader, and cars will be able to drive at full speed. Providers should remove all restrictions as well. Every mobile device and computer should have a high-frequency antenna that catches signals from an ultra-fast router. Several huge routers are located all over the planet. They look like enormous boxes without windows and with giant antennas on their roofs. Deep underground, thick cables providing ultra-fast data transmission are connected to these boxes. As soon as the signal from the cable enters the box, it broadcasts to space via radio waves. Thousands of satellites hover over the planet and intercept these waves to spread them throughout the world. So, anytime and anywhere, you have access to the internet that's working at the speed of light. Movies and video games are created several times faster. A lot of time is spent trying to transfer a terabyte of data with graphics from one computer to another, which is located in another country. Now, with Super Internet, developers get any amount of data in an instant. Flash drives and hard drives are no longer needed in the world. Everything is kept in cloud storage. From there, you can download any file to your computer thousands of times faster than if you downloaded it via USB. Companies that provide cloud storage services are becoming the richest in the world. You have access to the internet in the elevator and the subway, in the mines deep underground, and among the hot sands of the Sahara. The phones are released without internal memory and with an incredibly cool camera. You can record an infinite number of videos with 16K quality and not think about where to store them. You can do color correction, develop games, or edit your videos all on your phone. You don't need powerful processors for such operations. Everything works with the internet. You remotely connect to a powerful computer and work from anywhere. That's why the market for expensive computers has collapsed. Nobody wants to spend money on a cool graphics card because a new one will be released in a year. It's much easier to connect to the computer where it's already installed. Even in our time, such companies already exist in great numbers. You can play a new video game on top of settings on your old computer or phone if your internet connection is fast enough. Super Internet creates a perfect climate for the rapid development of modern technologies. Virtual reality lenses, for example. On an airplane, in a submarine, in the desert, you can watch the highest quality movies in 360 or play games with augmented reality. Special effects and graphics in such games become indistinguishable from reality. Artificial intelligence can process data from all over the world simultaneously, in seconds. Thanks to this, people make discoveries in the field of medicine and genetic engineering. Scientists are developing a machine that can upload the human mind on the internet and download it back. Each user's cloud storage accumulates so much digital garbage that people hire special companies to clean up terabytes of useless data. A huge amount of energy is consumed. It provokes an increase in the price of electricity. To save money, people build small wind farms in their backyards to generate electricity. Many people make tunnels to get to underground rivers. Using special equipment and a powerful water flow, you can create a home hydroelectric power plant. The roofs of most houses are covered with solar panels. The internet is becoming as familiar to the world as the air. There's no longer a place where you can't connect to the web. Some vloggers put a phone in a box made of refractory metals and threw it into the mouth of a raging volcano. Even then, the connection wasn't broken until the phone melted. In a few years, the data on the internet as a whole increases thousands of times. Billions of petabytes must be stored somewhere. Developers around the world build data centers to support cloud storage. They appear underwater, underground, in the mountains, and even in forests. Scientists understand there won't be enough space for such data storage in the future. In addition, all centers emit strong radiation, which is bad for humans and the Earth's atmosphere. Therefore, the world's IT companies unite to create a giant data storage server in space. They build such a station in the orbit of our planet. Developers install special equipment there to ensure the operation of cloud storage. Every year, the station grows in size. It receives energy from solar panels. After a few decades, the data center becomes a cube half the size of Earth. You can look out the window and see its outline in the blue sky, better than the moon. At night, millions of light bulbs glow on it. An enormous area on the moon is covered with solar batteries to provide the cube with additional energy. Now it looks like a disco ball. Humans colonize Mars and take the super internet there. Now you can make a high-quality video call to a friend who is on the red planet.
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risk, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the Dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 or 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shockwave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago. The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Oh no.
Stop shouting.
Huh? You can speak? No! No, no, no!
Don't even try to escape. Wow. Okay, I got it. Jeez. No need to swing your fists here. These savages can't even eat in peace.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths? There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing 1 revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for 1 person. And this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe's surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally, all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The Sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead?
The theory of parallel worlds has been discussed in the scientific community for a very long time. Unfortunately, we're not developed enough yet to prove or disprove it. But it's still an interesting theory, and that's why we have a lot of unusual urban legends about the guests from a parallel reality, according to many. Let's check out a few of them. A man from a non-existent country. This story took place in 1851 in a small German village, Frankfurt an der Oder. A lost man came out to the local villagers asking for help. The man introduced himself as Jopar Voren. He spoke very poor German and had a very strong accent. The man himself claimed that he speaks Laxar and Abram, languages that don't actually exist on our Earth. He claimed to be from Laxaria, a country on the mainland called Sacria, separated from Europe by a huge ocean. However, none of these places existed on the Earth's map. People sent Jopar to the local authorities. He talked to a psychiatrist, but the doctor concluded that the man was totally sane. An investigation by the local police also revealed nothing suspicious about him. Jopar Voren claimed that the purpose of his visit to Europe was to find his long-lost brother. He survived a shipwreck and found himself near the village. They showed him a map of the world and a globe and asked him to indicate the place where he crashed, but he didn't recognize anything familiar. He seemed to have extensive knowledge about his homeworld. Jopar named 5 main continents on it: Sacria, Aflar, Astar, Auslar, and Uplar. His story was considered plausible. Scientists from Frankfurt decided to send the man to Berlin for further research. However, during the trip, he had something like a seizure. The man suddenly jumped out of the carriage and disappeared into the surrounding forest. Despite a long and thorough search, no traces of Jopar were found. He seemed to have disappeared as mysteriously as he had appeared. Inspector Leboeuf, who was assigned to escort him to Berlin, thought this man could be a being from another world, and that he had returned from where he had come from. Lady on Highway 167. This incident happened on October 20th, 1969. It was first reported in 1988 in the magazine Strange. The article tells about 2 men, LC and his business partner, Charlie. The names are fictitious. One afternoon, LC and Charlie were driving along Highway 167 in southwest Louisiana. Discussing work, they drove toward the oil center of Lafayette. The highway was empty at first, but then the men noticed a very old and very slow car ahead. The men started discussing this mysterious car. Such cars hadn't been produced for several decades, but this one looked quite new. The men thought it was thanks to the owner's care and admired it. They slowed down to get a better look at the car. LC noticed a bright orange sign on it that said 1940. They saw a driver. It was a young woman in old-fashioned clothes, a hat with a long feather and a fur coat, even though it was warm outside. There was a child next to her, also dressed in a warm coat and a hat. LC and Charlie wanted to talk to her, but then they noticed the expression on her face. The woman was looking around in panic, almost on the verge of crying. LC called out to her and asked if she needed help. She nodded, and he gestured for her to park on the side of the road. But when the men also parked, they suddenly noticed that the woman's car had disappeared. They looked around the highway in shock. She couldn't have gone somewhere far so fast, but the car was nowhere to be found. After some time, another man drove up to LC and Charlie. He saw everything that happened and claimed that the car had simply disappeared. The men talked about the incident for several hours. When they reached the city, they contacted the police. However, the police couldn't help them in any way. Apart from their words, there was no confirmation of the existence of the car. The case was discussed for a while in local newspapers, and then was forgotten. The Gadianton Canyon Incident. This incident occurred in May of 1972 in southeastern Utah near the Modena Railroad crossing on the edge of the Escalante Desert. Jenna North was driving her father's 1971 Chevrolet Nova. Her friend, Carol Abbott, was in the passenger seat. In the back seat, there were 2 other girls, Lisa Rockford and Bethany Gordon. It was after 10 p.m. when the girls crossed the Utah-Nevada state line. They wanted to get back to campus before their housekeeper, Mrs. Mortensen, locked the dorm doors. This stretch of Highway 56 in Utah is pretty deserted. There's nothing there but sand and a few plants. The girls were very happy when they finally noticed the Union Pacific Railroad crossing in Modena. But right behind the railing, Jenna noticed two highways. One went into the desert, and the other to Gadianton Canyon. The girls decided to take the road to the canyon. They thought it would be a shortcut to campus. The other girls were chatting with each other when Jenna noticed that they were no longer driving on asphalt, but on white cement. "Watch out!" suddenly shouted one of the girls. The road ended abruptly at a high rock wall. It was a dead end. They had to go back the same way they came here. And while Jenna's friends were complaining that now they would have to sleep in the car, Jenna saw that the landscape had changed dramatically. They weren't in the desert anymore. Instead, the canyon turned into an open area with wheat fields, pine thickets, and a small lake ahead. A full moon was shining in the sky, which was strange because it shouldn't have been there that night. The girls had no idea where they were, so they just drove to the light ahead. It was some building that they thought was a diner or restaurant. The girls saw a bright neon sign, but none of them could read what was written on it. These symbols were unlike any language they knew. Suddenly, several people came out of the building. They seemed shocked and frightened by Jenna's Chevrolet. They waved their hands and shouted something, but the girls didn't understand them. Lisa decided to ask the men for directions. She stuck her head out of the window and immediately let out a terrifying scream. "Get out of here!" she shouted to Jenna. The Chevrolet sped away from the building. Bright headlights illuminated their car from behind. They were being chased by a few vehicles. These vehicles were egg-shaped, had 3 wheels, and made a buzzing sound. The road ahead led back to the canyon. Jenna didn't have time to slow down and crashed right into it. The vehicles had disappeared, together with an unfamiliar landscape. The girls were back in the desert again. Fortunately, none of them were hurt, physically. But Lisa was in a state of shock. She was saying again and again, "They weren't human!" The girls had to help her walk. An hour later, they were able to stop a Utah Highway Patrol car. They told the police their story. The details of the report compiled by the police officer were complicated and confusing. During the investigation, the police couldn't figure out from the tire tracks exactly where the car went astray. The tracks ended very abruptly, as if the Chevrolet had suddenly disappeared. The police couldn't explain how the car could have driven 2 miles without leaving any traces, especially on such solid ground. There are still disputes about this story, but in the end, all versions and explanations of what happened are just guesses. Perhaps we'll never find out the truth. These were the urban legends about interdimensional traveling. Of course, there's no proof that any of these stories are real. Often the truth turns out to be very mundane. For example, the famous man from Taured, who people also called a guest from another reality, turned out to be a simple fraudster named John Allen Kuchar Zegras. But even so, these stories are still very interesting.
Wow, every morning 8.5 million people wake up in New York City. But the Big Apple doesn't belong only to humans. This is the city of ants. There are 17 billion of them here. They live in houses, hide in the grass, crawl under asphalt, and climb trees. For every New Yorker, there's a sneaker box filled with ants. City ants are more fortunate than their forest cousins. They don't have any need to look for food. Millions of people leave behind tons of hot dog crumbs, pizza slices, and coffee drips. Insects just have to wait for a lunch break in an office building. Then they gather around benches in the park or cafe tables. A lot of food is waiting for them there. Over 1 billion. That's how many ants are running through the streets and parks of Manhattan. And in this ocean of insects, scientists have been able to spot tiny reddish-brown creatures. These insects don't fit into any of the 13,000 ant species known to science. They're unique and only live in Manhattan. Their kingdom is between 63rd and 76th Streets. Scientists don't know how long the Manhattans have evolved in isolation. They arrived in the U.S. on ships from Europe and were cut off from the rest of the city's infrastructure. But why go anywhere else if there's enough food? The Manhattan loves fast food, especially corn syrup. Because of such a diet, The insect's body has an increased carbon content. This isn't a problem for the ant, though. Carbon helps it adapt to the dry, warm weather of the concrete jungle. Around 20% of New York City is parks and green spaces. White-footed mice live in these places. Scientists have found out that the mice that live in New York have evolved. They're different from their village relatives. These changes are genetical. It's caused by the diet of white-footed rodents that feed on human food waste. For example, New York mice need enlarged livers to process fatty acids from fast food. Central Park in New York is almost twice the size of the Principality of Monaco. A unique centipede is only found in this green area. The creature, called Hoffman's dwarf centipede, doesn't grow any longer than 0.4 inches. It lives in heaps of dry plants and runs on 41 pairs of legs. This crustacean, measuring only a bit more than 0.3 inches, is called the Socorro isopod. It's one of the rarest animals on the planet. The creature can only be found in a small thermal spring near Socorro, New Mexico. The isopod lives in the water as warm as 90 degrees Fahrenheit and covered with a layer of algae. These are ideal conditions for the creature. To get to Mobile Cave, you'd have to rappel 65 feet down. That's the height of a 4-story building. After that, you'd crawl through narrow passages and swim along a canal with cold water. Sunlight can't get into the cave. The air is poisoned by vapors of ammonia and hydrogen sulfide. This extreme place has been isolated from the outside world for 5.5 million years. A unique ecosystem has formed in this toxic atmosphere. Of all the animals that live there, 33 species of millipedes, scorpions, spiders, and leeches can't be found anywhere else on Earth. These creatures are mostly blind and colorless. Well, why would you need eyes and disguise if you live in complete darkness? Mobile's coolest guy is the venomous centipede. Scientists have nicknamed this animal the king of the cave. It doesn't grow more than 2 inches, but for this world, it's a giant. The blind salamander would feel great in the company of strange animals from Mobile, but these little monsters are separated by the ocean and thousands of miles. The Mobile Cave is located in Romania, where these beauties live only in Texas. Their home is an underground body of water in the San Marcos area. These salamanders grow to be 5 inches long. The name makes it pretty clear that the animal is blind. It does have eyes, but they're pretty much useless. This doesn't stop the salamander from being a skilled snail and shrimp hunter. It senses other animals by feeling the underwater waves they create while moving. The Scottish wildcat lives in the north of Scotland. This animal is different from domestic cats, which love sleeping on the couch. Unlike them, it's a perfect hunter. The creature is 25% larger than the average cat. It's muscular and long-legged. The wildcat's tail is blunt and fluffy, covered in black rings with a black tip on the end. The quokka is called the world's happiest animal. Just look at its smile. This fluffy animal seems to always be ready for a photo shoot. Quokkas are only found in Australia. Around 10,000 animals live on Rottnest Island and several other locations. The creature's cute smile is an evolutionary trait. An open mouth helps it breathe and regulates its body temperature. Oh, by the way, if you try to feed a quokka, you'll have to pay a fine of more than $200. This baby will feel comfortable even if you put it on your little finger. The animal lives only on the island of Madagascar. Scientists have found just 2 tiny reptiles, a male and a female. The researchers have named the nano-chameleon Brookesia nana. It's a mystery to them why it doesn't grow larger than a sunflower seed. The next animal on the list also lives only in Madagascar. Locals call this creature Ai. The unusual lemur spends most of its life in trees and leads a nocturnal lifestyle. This might explain why it looks so tired. Even though the Ai is a lemur, its teeth are like those of a rodent. Its claws resemble sloth's claws, and its body looks like that of a monkey. The animal's fingers and toes are especially frightening. They're long and thin, with pointy claws. Get equipped for any season with brand new Brightside merch. Click the link and grab your print. This is a giraffe with its trademark long neck. A zebra is grazing nearby. Black and white stripes on its body help the animal reflect sunlight during the day and keep it warm at night. But what if you combine these animals? No need, nature has done this work for you. The okapi looks like a giraffe with a short neck, horse body, and zebra stripes on its legs. The okapi has a long tongue. Males have small giraffe horns on their heads. You can only meet these unusual animals in the African rainforest. If you decide to travel around Africa afterward, you must visit the Ethiopian highlands. That's where you see unique gelada monkeys. And no, they're not named after the Italian ice cream. That's gelato. Don't mix that up. Males look like rock stars from the 70s. They're bright and have cool hair. But don't mess with these animals. They aren't too friendly. Geladas spend most of their time on the ground, and the main part of their diet is the grass they collect during the day. Scientists believe that geladas are the remaining members of an ancient gang of critters. It lived millions of years ago in vast spaces from South Africa to India. Now, imagine people the size of the Statue of Liberty living next to us. Sounds like science fiction. But for the animal world, this is reality. The world's smallest tortoise species, the speckled tortoise, doesn't grow more than 4 inches long. But the Galapagos Islands are home to giant tortoises that reach the length of 5 feet. They also weigh like a sports bike. The largest of them had an incredible weight of 1,000 pounds. The giant Galapagos tortoise lives for 100 years and sleeps 16 hours a day. Due to its slow metabolism, the animal may not eat or drink water for a whole year. Millions of years ago, lizards from South America climbed onto a log. Sea waves carried the log to the Pacific Ocean. The lizards traveled hundreds of miles and ended up on the Galapagos Islands. They had to evolve to adapt to new conditions. Scientists believe this is how the marine iguanas appeared. These unique animals look like dangerous dragons, but in fact, they feed on plants and are totally harmless. Iguanas spend most of their lives in water. To get rid of sea salt that accumulates in the body, these animals literally sneeze salt. Achoo! The lyrebird lives only in southeastern Australia and the island of Tasmania. The bird has such a strange name because of its tail. It looks like a lyre, a stringed instrument of the ancient Greeks. Lyrebirds are known for their ability to imitate other birds, and not only them. The bird copies animal screams, human voices, chainsaw noises, car and fire alarms, and even the click of a camera. About 12,000 years ago, a salt lake appeared on one of Palau's islands. Today, it's called Jellyfish Lake. This 1,500 by 500-foot reservoir is home to 5 million golden jellyfish. These unique creatures swim to the west shore of the lake every morning. There, jellyfish wait for the sunrise. Then, all day long, they follow the sun. Algae lives in the tissues of the jellyfish, feeding them with energy. These algae can't live without sunlight. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour. And as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as Tech-tites. Tech-tites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark glassy pebbles. A trail of these Tech-tites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But Tech-tites were too widespread. That's why they couldn't pinpoint the exact location until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of Tech-tites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world, as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicougan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater. Wow, looky here! It's New York City, the Big Apple, the city that never sleeps. Hong Kong on the Hudson, the greatest city in the world. New York, New York, the city so nice they named it twice. Alright, I'll stop. You thought you knew this city so well, but underneath all that glitz and glamour is a facade, literally. New York is populated with some of the most iconic urban buildings in the world and home to some of the most unique and famous towers. Who would have known that New York was a front for fake buildings? And the cool thing is that there are plenty to search for. Okay, I'm adding that to my bucket list. So the question is, why do they put these fake buildings all over New York? The city is one of the most vibrant places in the world and requires many infrastructures to keep the city in motion. That means having many industrial structures and buildings in every major district. New York is charming for the design and the buildings. Imagine having industrial structures right next to your favorite pizza parlor or hot dog stand. The designers thought ahead and decided to disguise those industrial infrastructures as fake buildings. They blend with the city so well that they don't stand out. They look like your good old apartment or housing unit with a front door, real-life windows, and even charming balconies where people would hang out. The only thing is that there's nothing behind the facade and no one is allowed inside. So, where in the world can you find these fake buildings? For starters, one of the most popular fake buildings is in Brooklyn. At 58 Joralemon Street, you can find a very typical neighborhood. But between the buildings stands a brick building with a slightly deeper shade than the rest. It has bright open windows that blend in with the rest of the buildings in the neighborhood, except that they're blacked out. At first glance, you might not think of it as anything, but if you pay close attention, the building looks like a glitch from a video game. It was built in 1847, way before New York was considered glamorous. Originally, it was meant to be a regular building, but in 1908, they converted it into a fake building. Don't think you can just try to break in. Even if you could, it's pointless, because it's part of a ventilation fan for the subway. It also serves as an emergency exit for some of the surrounding buildings. Actually, throughout New York, many fake buildings exist to disguise the subway vents for the smoke to escape. All the way to 415 Bruckner Boulevard, the Bronx, this townhouse was designed by the Switzer Group, which is an interior architect company. It's not as charming as the one at 58 Joralemon Street, but it serves a similar purpose: to hide an electric substation for New York's utility company. The city needs these substations to reduce the high-voltage electricity to a lower voltage so it can be distributed locally. Having a building like this popping out of the middle of your neighborhood isn't exactly the smartest way to attract people to the Bronx. That's why the fake townhouse facade is the perfect camouflage. Now, some of these fake buildings don't really hit the mark and stick out like a sore thumb. The people of Manhattan describe the Mulberry Square infrastructure as a complete clunker. After plenty of redesigns and back to the drawing board meetings, the result is still not pretty. The locals compare it to a concrete box. They created windows without glass, which doesn't allow the building to blend in with the rest of the neighborhood. But it beats a typical subway ventilation plant either way. There are just so many places to visit and cross off your bucket list. But if you live in China, you can literally stay in the country and visit many iconic cities around the world. The replica cities began when the Chinese economy started booming in the early 90s. They wanted the lifestyle of the rich and famous without wanting to leave their country. They can be comfortable eating their local food and get the feeling of being abroad. The Chinese province of Guangdong has an identical copy of the historical Australian alpine village Hallstatt. The real Hallstatt is centuries old and one of the most charming places to discover. The local people of Hallstatt also had no idea that their home was being built in China. Some people thought that this was controversial, probably because it cost around $940 million to build it. Paris is undoubtedly one of the most charming cities you could ever visit. Its rich history and vibrant culture are enough to catch the first plane to go there. For residents of Tiandu-Cheng, that's something they can do anytime they want. The city is also known as Sky City and has a replica of the Eiffel Tower that looks eerily like the iconic one in Paris and built buildings to match the city's visual charm. One of the main things that will break the charm is the farmland surrounding the city. There's barely anyone there, and the streets are always empty, very un-Paris-like. Still, you can find some nice fountains and statues scattered along the streets to give it some spirit. There's laundry hung everywhere, even on the trees. The picturesque fountains are dry and many apartments are empty. Only a few stores are open for business. Even though this looks like a fake city, it's quite real. Some people live here because it's more affordable than other places. 2 hours away from this town is another version of Paris's Pont Alexandre III and a carbon copy of London's Tower Bridge, but with 4 towers instead of 2. Hey, such a bargain! You can also visit the closest thing to Italy, but this time you can go shopping. Florentia Village is an outlet mall that offers an array of shops to lose yourself. The good thing is that this was built by an Italian developer to capture the essence of an Italian village. It has fountains, canals, and mosaics for proper aesthetics. It began in 2011 and has more than 200 shops with many Italian brands and British, US, and Chinese brands as well. The place is so popular that it gets between 10,000 and 25,000 visitors per day. China also has other replica towns that put you in a mini Manhattan called the Yujiapu Financial District. The developer's goal was to make this place the financial center of the world. It was complete with the right landmarks, like the Rockefeller and Lincoln Centers, but the project was halted in 2019, leaving it mainly empty. You can find a typical English town with cobbled streets, Victorian homes, and restaurants that make Thames Town. This place was meant to recreate a European lifestyle fantasy without leaving Shanghai. China also has a Dutch town that has some elements of Amsterdam with windmills and famous canals. They even decided to copy some of the landmarks, like the Netherlands Maritime Museum. Here's a bonus story of Lebanon's thinnest building built out of a dispute. It's the story of 2 brothers who both inherited unequal plots of land. One of the brothers happened to get a very thin plot of land and couldn't help but be jealous of his brother's nice plot of land. He wasn't pleased. Both of the lands overlooked the Mediterranean Sea in a lively neighborhood of Beirut. So it's no wonder that both brothers couldn't agree on how they should develop their lands. It was obvious that the brother with the most land could build a proper building. The other brother had to improvise. He decided to obstruct his brother's property by constructing a thin building enough to only fit 14 feet at its widest and 2 feet at its most narrow. It was constructed in 1954, and the locals of the area know it as the Grudge. The crazy thing is that the place was once habitable with many visitors enjoying their stay. It's not easy to live there, but it's part of living the experience. The building is still standing, but is empty. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Paul. Paul is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Paul crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the models showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh.
Here's a riddle. Which U.S. city is so loved that its name should be repeated twice? You guessed it, New York, New York. But the thing is, how much of New York do we really know? I'm talking about the city that lies under the city. Dare to join me on an underground tour of the Big Apple? Then grab a flashlight. It's about to get dark. We'll start in the heart of Manhattan, in the front of the Romanesque City Hall building. Believe it or not, beneath our feet lies New York's oldest subway station, known as the Old City Hall Station. It opened in 1904 on October 27th, a night of true celebration for New Yorkers. People were so excited, some of them spent the entire night riding the trains back and forth. Before this, urban dwellers moved around in carriages pulled by horses. No wonder the subway was such a hit. You might feel like a time traveler stepping inside the Old City Hall Station. The architecture is dazzling and one of a kind. They sure don't make subway stations like this one anymore. Fun fact, the Old City Hall Station would cost $6.2 million if it was built today. Back in the day, it had dozens of brass chandeliers hanging around. It was one of the few spots in town with functioning electricity. And oh, not to mention brand new multicolored tiled arches and stained glass ceilings you can still see today. Impressive, huh? If you decide to wander down the tracks, you might be in for a treat. Underground New York is as fascinating as the city above the ground. But one thing we usually take for granted is the behind the scenes of what the Big Apple needs to function. Down here, you might see one or two of New York's pneumatic mail tubes. These tubes were built back in the 1800s and they were operational up until the 1950s. They were responsible for distributing people's mail through different post offices. Letters flew at an impressive speed of 35 miles per hour. That's almost as fast as a professional runner. It sure sounds like a useful system. But I have to say, it feels weird imagining people's correspondence flying around 15 feet underground. Back to street level. We'll wander around fancy Lexington and Park Avenues. If you look up, you'll see the famous Waldorf Astoria 5-star hotel. Many celebrities have stayed there, including John Lennon and Yoko Ono, as well as presidents such as FDR. This is why the hotel used a secret infrastructure to sneak people inside and out. Under the building, a tunnel known as Track 61 connected the Waldorf Astoria to Grand Central Station. The track was deactivated in the late 70s, but some people say Andy Warhol threw a party there in the 80s. I bet that was something. For the next part of our visit, we'll have to take the subway uptown. We'll get off at 125th Street and find ourselves on the scenic waterfront of Riverside Park. Here, you'll find abandoned tracks of an old metro line. If you follow the tracks, you'll get to an underground graffiti gallery, aka the Freedom Tunnel. The tunnel is named after a graffiti artist from the 80s, who is commonly known as Freedom. While exploring these tunnels, we'll see over 40 graffiti pieces he painted over 15 years. There are spray paints of James Dean, Mona Lisa, and even a self-portrait of Freedom himself. Moving on, let's wander around the northern part of NYC for a bit. Walking in Van Cortlandt Park will feel like hiking upstate, but believe me, you're still in the city. Along the way, you'll encounter some big ventilation towers made of stone. These towers were once part of an old New York infrastructure. They make up the remains of what used to be the Croton Aqueduct. In the 1800s, the city's water supply flowed through a 41-mile-long underground tunnel, all the way from Croton River in upstate New York to Bryant Park in Midtown Manhattan. Oh yes, and I should probably tell you that Bryant Park wasn't a park. Instead, it hosted a colossal stone structure that looked pretty much like something ancient Egyptians would build. This 4-acre structure served as the city's water reservoir. It even had a pathway on top so that people could enjoy a nice afternoon stroll while looking at the reservoir's crystalline water. Now, all this exploring might have made you hungry, but don't worry, our next stop includes a yummy treat. We'll have to leave Manhattan and make our way to Brooklyn. In case you didn't know, New York City is made of 5 boroughs: Manhattan, Queens, Bronx, Staten Island, and Brooklyn. Crown Heights, that's our stop. Would you believe me if I told you that beneath these streets lie caves full of aging cheese? How very Parisian of them. To get down there, you'll have to make your way through a century-old building that now works as an office space. Maybe wave hello to all those hard-working people and disappear in one of the stairways that will take you 30 feet below the ground. You won't need a flashlight for this one. The caves are bright and renovated and can hold up to 22,000 pounds of cheese. But hey, it might stink. That's the main reason cheesemakers decided to use underground tunnels to age cheese in the first place. After a bite or two of some delicious cheese, let's keep going. While still in Brooklyn, you might see tons of locals enjoying a sunny day in the McCarran Park pool. This pool is a huge attraction, being 3 times the size of an Olympic pool. As the NYC explorer you are becoming, you might even go for a swim. But hey, there's a much more interesting part to this attraction. The pool was built in the early 1900s, but it was shut down in the 50s. During this time, urban explorers discovered a network of underground tunnels right beneath the pool. And, of course, you can find a secret entrance and get a peek for yourself. There, you'll not only see the pool's filtration and heating system, but also a lot of graffiti from the time the site was abandoned. Neat! This question may sound weird, but have you ever seen a cow in New York? I sure haven't. Well, maybe there's a reason for that. Apparently, New York still has underground tunnels that were constructed for the transportation of cattle. Once New York started to flood with automobiles, cows became a burden for traffic. Until a 200-foot-long cow passage was built below 12th Street to transport the livestock that was ferried over from New Jersey. These days, you won't be able to visit this place in person because the tunnel was most likely destroyed. but historians found blueprints proving its existence. To add to the list, archaeologists discovered a very peculiar fossil a while back. Now imagine peeling off the layers of the city's soil. First, at 15 inches, you'll find a layer of wires. I'm talking TV cables, electricity, and all that. Digging deeper, at 4 feet, you'll see water and sewage pipes. But then, at 15 feet down under the surface of NYC, diggers have found a fossilized shipwreck. The wreck is located right under Broad Street, where there was once shallow water. They believe the wreck dates back to the 1600s. It's 92 feet long and 25 feet wide. Oh, and that's not all. At the intersection of Bowery and Canal Street, engineers stumbled upon a room with its walls and ceiling covered in mirrors. And no one has managed to explain the existence of this bizarre place yet. Our Big Apple underground visit is coming to an end, but we sure did more than just scratch the surface on this one. Before we finish, let's enjoy the best of what NYC cuisine has to offer, a good old bagel. Who knows, maybe next time we'll do Paris or even London. See you soon, explorer.
Flies and other bugs have developed vision, which helps them to react quickly to danger and see in all directions at once. They can easily notice a huge object approaching them and quickly fly away. But when they're flying at a high speed, their vision loses focus and the image of the world becomes blurred. They can't understand that there's a transparent glass in front of them or a human, so they crash into them. Many beetles are guided by light and temperature. They're flying in the fresh air and suddenly notice the light and feel the heat from the window. A bug heads towards the light and doesn't notice the window. Their vision is not developed enough to distinguish a thin layer of glass in their way. They are also attracted by the smells coming from the house. Most insects don't have sharp vision. A bug flies quickly along the road towards a fast-moving vehicle. The insect notices it too late and simply doesn't have time to react and fly away. The fly's vision is not so bad. When trying to get rid of a fly, you hit it with a newspaper, but the insect easily gets away. Its speed is not so fast for its size, but you're still too slow for it. The tiny fly's brain reacts to what it sees several times faster. The fly perceives 1 second 5 to 6 times slower than a human. Imagine a scuba diver running underwater. If you look at them from the surface, they will seem slow to you. That's how a fly sees you from the outside. Throw an ordinary balloon in the air and watch it fall to the ground. For a fly, your hitting hand is not any faster than this balloon. These insects also have unique eyes. They are divided into thousands of receptors and lenses that simultaneously capture light. People use small muscles and turn their eyes to see their surroundings. Flies don't have such muscles. They see in all directions at once. With their 360-degree vision, no matter from which side you attack the fly, it will never be surprised. Flies also have amazing wings, allowing them to change direction during the flight. It can stop, turn around, move in a new direction, and dodge any obstacles in a split second. But the most incredible thing about flies is the ability to calculate their flight strategy in advance. You swing a rolled-up newspaper at a fly. At this moment, the insect's brain calculates where your hand is going to land. The fly's body immediately takes the right position to perform the maneuver. It knows where you're going to hit before you hit. But you have a small chance to swat a fly. Play ahead of the curve. A fly is sitting on your desk. You need to aim at it, but hit a little further, to the place where the fly could possibly move. Anyway, it's difficult to predict its route. Despite your slowness, you're still a big danger to a fly, but for some reason, it's not afraid of you. The fly is moving around your body and doesn't leave you alone. It's because your body is a feast for the fly. It doesn't even need to bite you to get food. Everything is on the surface. Your skin secretes sweat, proteins, carbohydrates, salts, sugar, and other chemicals the fly collects with its feeding tube. Its main obstacle on the way to food is a slow giant, you. And you're not a serious reason to stay hungry. Have you noticed hundreds of moths and night butterflies flying around a lantern or an ordinary lamp? This happens because of their evolution. These insects fly only at night to avoid meeting with predators. For millions of years, they were flying through the night sky guided by the moonlight. But they weren't flying straight to the moon. They had to see the moon at a certain angle. This helped them not to get lost or fall into traps. They know there were fewer dangers where the moon was shining, as there would be an open space there. But then, people created electricity. Millions of new moons appeared from windows of our houses to street lamps. A moth flies to the lamp at a certain angle, but unlike the real moon, the lamp is getting closer and closer to the moth. There's more and more light, and the moth is lost in space. It begins to fly in a spiral towards the lamp and gets so close that the light blinds the moth from all sides. It's disoriented and can't understand what's happening. The light that shows the direction to the moth is everywhere, so the insects can't fly away. It just doesn't know where to go. Crane flies are huge insects with long legs. They live near water and moist places with large vegetation. They seem quite scary because they look like huge mosquitoes. But crane flies are some of the most gentle and harmless insects on the planet. Some species feed on nectar from plants. Some crane flies don't have a mouth and don't eat anything at all. They live a short life and use fat reserves they accumulated when they were larvae. These fragile creatures appear after winter. Crane flies play an important role in maintaining the environment. They are food for frogs, fish, birds, spiders, and bigger insects. So don't rush to slam it if you see it. It won't harm you. Most insects can be annoying, and some, like house centipedes, look pretty scary too. These long-bodied creatures with 15 legs can live in your bathroom or even in your bedroom. Most people immediately want to strike it, but you shouldn't do this. A centipede is a useful predator for your home. It catches small insect pests, controls the population of cockroaches, midges, flies, termites, and other beetles. The centipede likes to hang out around food. If you crush it, a lot of small insects will crawl out of your house. It's better to call special services to etch out all unwanted bugs and cockroaches. Once there's no food for it in your house, the centipede will leave it. Centipedes are solitary predators. They are not carriers of diseases. They don't chew on your furniture or clothes. They don't build nests. All they want is to catch prey. The same goes for spiders. They catch bedbugs, mosquitoes, flies, and other small insects. So, spiders and centipedes are the little guardians of your home. Giant tropical centipedes are totally different. These huge creatures are poisonous and can even bite a human. They also have a strong protective shell, which is difficult to destroy. They usually live in tropical forests and jungles, but sometimes they can crawl into houses. There's a fast insect hiding in the walls of your rooms or behind the stove in your kitchen. Meet American cockroach. It's almost impossible to catch it as it can move at the speed of 5 feet per second, thanks to its 6 legs. Each leg has 3 knees. Their limbs are covered with small hairs that feel any change in vibrations in space. They work as antennae. When you open the kitchen door, they immediately catch a whiff of air and quickly run away. You can't catch them, but house centipedes can. The fastest land animal in the world relative to its size is as large as a sesame seed. It's a mite found in Southern California. It runs 322 lengths of its body in a second. For comparison, the fastest mammal is a cheetah. It can run 16 lengths of its body. The fastest athlete runs 6 lengths of their body. If you increase the mite to the size of a human, it would be able to move at a speed of 1,300 miles per hour, almost 2 times faster than the speed of sound. It can change its direction so quickly, you can also call it the most elusive creature on the planet. You won't even see it if the bug runs past.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone, the size of dozens of Everests, will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
So, what would it look like to go around Earth at the speed of light? Well, I'm guessing pretty quickly, but let's get to the details. Traveling around Earth at the speed of light would be an astonishing sight to behold. If we could magically achieve such a feat, here's what it would look like. As you kicked off your speedy journey, everything around you would get blurred. The landscape would transform into a streak of dazzling lights, like a cosmic fireworks show on Fast Forward. The world would appear distorted, with buildings and landmarks merging into streaks of brilliance as you zip past them. The familiar features of cities would become blur colors, blending together in a mesmerizing display. Day and night would blend seamlessly, since Earth's rotation would become an indistinguishable whirlwind. However, keep in mind that at the speed of light, time itself would behave strangely. To you, the journey might feel instantaneous, but when you return, you'll find that much more time has passed for everyone else. It's like taking a lightning-fast trip while the rest of the world ages. Sadly, achieving the speed of light is currently beyond our technological capabilities. Okay, but do you know what the speed of light actually is? In the vast expanse of empty space, the velocity at which light travels is an astonishingly precise figure. This translates to approximately 186,000 miles per second, a universally recognized constant notated as c, or the speed of light. Drawing from the revolutionary principles of physicist Albert Einstein's theory of special relativity, which forms the bedrock of modern physics, we come to a remarkable realization: nothing in the entire universe can surpass the velocity of light. According to this theory, as an object comes close to the speed of light, its mass spirals toward infinity. Consequently, the speed of light operates as an indisputable cosmic speed limit, casting its influence over the entirety of the universe. Such is the fixity of light's rapidity, yes, I have a thesaurus, that it finds purpose in defining internationally accepted units of measurement, like the meter and mile. The United States National Institute of Standards and Technology reveals that the speed of light even contributes to the definition of the kilogram and the temperature unit known as the Kelvin. Now, let's talk about the speed of dark. Darkness, the elusive counterpart of light, seemingly travels at the speed of light itself. In reality, Darkness doesn't exist as a distinct physical entity, but is rather the absence of light. Whenever you block out a substantial portion of light, like when you cup your hands together, darkness fills the void. When discussing speeds, we can think of darkness as what emerges once the light ceases to illuminate, and it appears to move at the speed of light. Still with me? Yeah, my brain is starting to ooze out my ears too. Anyway, let's take a journey to distant space, far away from any light sources, such as the radiant sun. Imagine having a light bulb attached to the nose of your spaceship, emitting its luminosity in all directions through space at the speed of light. Now, if you momentarily turn off the light bulb and then turn it back on, a fascinating phenomenon occurs. Light continues to travel outward in all directions from before you dim the bulb, and subsequent light beams follow after you restore its glow. However, amidst these expanding spheres of light, an intriguing region emerges. It's the space in between there was no light because none was generated during the brief period when the bulb was off. So, in this cosmic spectacle, darkness appears to join the journey alongside light, seemingly chasing it at the speed of light. It reminds us that even in the absence of light, there is an enchanting interplay between shadows and illumination, each playing its unique role in the vast tapestry of the universe.